that physics and technology has a strong bond. Now, when we talk about physics or nature or natural phenomena, there is one critical thing that plays a very crucial role, and that is force. Now, we have all learnt about forces in our junior classes, and here in this video we are not getting into the detail of these forces, but what we will do is we will get a quick understanding of the forces which naturally exist, like they are there in nature. So we will learn about these type of forces. Now, even before we talk about these types of forces, let's do a quick recap on force. What is force? A push or pull that can cause an object change its velocity or change its shape. Let's look at this ball. It's spherical in shape. Now, the moment I apply a lot of pressure in it, the shape kind of changes. Ball pichak sa gaya hai, right? So there's a change in shape. Looking at the ball again, it's at rest right now. But the moment I apply a force on it, its velocity would change. There are two types of forces: fundamental force and derived force. Now, fundamental forces are those forces which naturally exist. So they exist in nature on their own. And there are four types of fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Now, coming back to the derived forces, these are the forces which are derived from the fundamental forces in some or the other way. So, if we think of examples of derived forces, all other forces that we talk about, whether it is the spring force, muscular force, friction, they all come under this category of derived forces. So, in this video, as I had earlier mentioned, we are just going to focus on the forces that exist naturally. That is, these four types of fundamental forces. Gravitational force. Gravitation word से ही हमें याद आता है apple and the tree. Apple पेड़ से नीचे गिरा. So that has kind of become the view of gravitational force. So this gravitational force is a universal force, not just the apple and the tree. It exists between any two objects. If we talk about the nature of this force, it is a mutually attractive force. The magnitude of this force depends upon the masses of these two bodies and also the distance between them. अगर दोनों ऑब्जेक्ट के बीच का डिस्टेंस बहुत ज़्यादा है तो ग्रेविटेशनल फोर्स कम होगा, और अगर इनका डिस्टेंस कम है तो ग्रेविटेशनल फोर्स ज़्यादा होगा. देयर इज नो मीडियम रिक्वायर्ड फॉर दिस फोर्स एंड ग्रेविटेशनल फोर्स इज द वीकेस्ट ऑफ ऑल द फोर्सेस. इन फैक्ट, द मून मूविंग अराउंड द अर्थ is also an example of the gravitational force. Had there been no gravitational force, in that case the moon would have not been moving around the earth and would have fallen back somewhere. Electromagnetic force. नाम से ही लग रहा है कुछ तो इलेक्ट्रिक मैग्नेटिक कुछ तो है. This force is all about charges. So this force exists between charged particles. तो अब चार्ज्ड पार्टिकल्स पॉजिटिवली चार्ज भी हो सकते हैं, नेगेटिवली चार्ज भी हो सकते हैं, विच इन अ वे टेल्स अस कि ये जो फोर्स है ये अट्रैक्टिव भी हो सकता है और रिपल्सिव भी हो सकता है, क्योंकि अगर ये फोर्स दो लाइक चार्जेस के बीच में होगा तो रिपल्सिव होगा, अगर दो अनलाइक चार्जेस के बीच में होगा तो अट्रैक्टिव होगा. Again, this force also doesn't need any medium, and this force is 10 to the power 38 times stronger than the gravitational force. तो gravitational force से तो ये बहुत 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 ज़्यादा strong force है. अब बारी है strong nuclear force की. Force के नाम में ही strong है. क्यों? क्योंकि this is the strongest force. Force के नाम में nuclear भी है. क्यों? Because this force exists within the nucleus. अगर विद इन द न्यूक्लियस है तो ये फोर्स किसके बीच में होगा? न्यूक्लियस के अंदर कौन होता है? न्यूक्लियस के अंदर होता है प्रोटॉन्स एंड न्यूट्रॉन्स. प्रोटॉन्स जो कि पॉजिटिवली चार्ज्ड है एंड न्यूट्रॉन्स जिनमें कोई चार्ज नहीं होता है. तो इसका ये भी मतलब है कि इस तरह का जो फोर्स है दिस इज इंडिपेंडेंट ऑफ चार्ज. इट डजंट मैटर वेदर इट इज पॉजिटिवली और नेगेटिवली और न्यूट्रल. It is charged independent force and this is the strongest of all force. Finally, the fourth one, that is weak nuclear force. So this is also a nuclear force. So this also exists within the nucleus, but this is a very weak force, and this force comes into picture when we talk about the phenomenon of radioactive decay. We have learned about radioactivity. If we haven't, we are going to learn about it very soon. So radioactivity is a phenomenon which takes place only in heavy nuclei, where we see that a particular nucleus emits an alpha particle or a beta particle. So I'm not getting into the detail of that, but this entire phenomenon of radioactivity takes place, and there this weak nuclear force plays a role. But this is a weak force. So we have learned about the 4 types of fundamental forces so far. Now if I ask you, out of these 4 forces, there are 2 forces which operate over very short distances. Can you guess which are those 2 forces? Quite simple. There are 2 forces which operate within the nucleus: strong nuclear force and weak nuclear force. Now nucleus is a very short range thing, right? And that is why these 2 types of forces are also termed as short range forces. On the other hand, if we talk about the gravitational force or the electromagnetic force, they operate over larger distances, and therefore they are also termed as the long range forces.